The group that I'm involved with, the National Hypersonic Science Research Center, it's a group of 6 American universities and me at Canterbury University. What their aim is not so much to generate a vehicle, but to understand the science of what would happen to the materials if you were to have a craft that could go at hypersonic speeds. There are some vehicles that already go at supersonic speeds, but the hypersonic speeds they're talking about is 10 times that, so 10 times the speed of sound. And we know one of the biggest things is that if you're going to push through air that fast, you're going to get a very hot structure. Whatever's pushing through it is going to heat up. And we all know that from seeing the re-entry of existing space vehicles, that they get very hot as they go fast through the atmosphere. So there's several ways to keep a craft that is being heated by traveling fast through the atmosphere from burning up. You can put on a sacrificial layer on the outside, an ablative layer. You can put on insulating, and you can have cooling. And if you were going to go Mach 10, they're pretty sure we'll need all of them. Because as an object goes through the air that fast, the aerodynamics are going to become such that it just doesn't matter anymore. You can't just push the air out of the way and have it go around you. You're just going to be smashing through it. And so the heating on the front edge of the wings and the nose of that craft is going to be really extreme. So we're going to need a layer that protects against chemical attack and that has a good insulation value to protect the rest of the structure. There are many different angles to the materials science of a possible hypersonic craft, and my role is process engineering. So process development for a thin ceramic coating. Ceramic materials, everybody's actually quite familiar with them. They're like your teacup or your dinner plate, and they're very heat resistant and chemical resistant, very nice durable materials, but you also know they're very brittle. They break pretty easy. And so we can't make whole objects out of them that are going to undergo stresses and strains, and you can't machine them either. I mean, just think about trying to cut something like a teacup. It just breaks all apart. So we want to make objects out of metals, but we'd love to have the surface properties that you have of ceramics. So we want to deposit that ceramic material on the outside of the metal, and the way we're going to do it is to grow it on there. If you're going to grow crystals, you have to have molecules that arrive and can find a nice place in the crystal, and then the crystal grows. So chemical vapor deposition is the manufacturing process, and we want to deposit a ceramic material onto another surface that's called a substrate. We're just going to try out a lot of things and see what we get. And I will send the samples to my colleagues in the United States who have high temperature testing facilities, and they will destroy my little samples and see how they did. We might call it destructive testing.